This is part 2 of ionic bonding.
Which is ionic compounds with transition metals.
Yeah, honestly, this isn't much different than what we just did in part 1.
Transition metals are the middle section of the periodic table. That little island, not an island, but that little kind of recessed portion from columns or groups 3 through 12. They form more than one ion.
So, an example here is iron. Iron sometimes will lose 2 electrons, and other times iron loses 3 electrons, depending on what it's bonding with. It can lose either one.
So multiple charges.
Yeah.
Okay, those are kind of tricky. To distinguish between the two different types, we have to use Roman numerals to say what charge of the transition metal. What is the charge of the transition metal? So we could have iron oxide, and it could mean 2 different things. So same as we did before, except with Roman numerals, because those are the transition metals.
All right, so the hardest part about the naming compounds here is being able to determine what Roman numeral we're going to use, because since these can have multiple charges, we have to be able to specify that in the name. And we use a Roman numeral to do that, because it would just be really confusing if we didn't. So we're going to have to use the charge and how many of the anion are in the formula. So there actually is a little bit of a process involved here.
And we're just trying to do some simple math to figure out the charge. So
chromium something bromide. Chromium is an element that can form either a, let's see.
This is on the back of your periodic table.
Right, either a +2 or a +3 charge. So we're just trying to figure out, based on the formula CrBr3, what's the charge of the chromium? Well, we know the bromine is -1 because that's the column it's in the periodic table. Okay, so just do a little bit of math to figure this out. If we have 3 bromines and they have a -1 charge, that gives us a total of a -3 charge. You can see down below that math, we've got our question mark for chromium.
Because we don't know the charge of it.
Right. We have one of those in the compound because there is no subscript next to chromium. And so we want to know what times 1 equals 3. Hopefully this is pretty obvious that it's 3.
Because they need to balance out to equal 0. So -3 and +3 are 0. And that means that it has a +3 charge. That will cancel them out. So, in this case, that is chromium 3. And that's all we're really trying to figure out.
So when we name it, it's chromium, Roman numeral 3, bromide.
So the Roman numeral, if you're looking for a set of rules, write this down if you would like. The Roman numeral comes after the anion, and the Roman numeral number is the charge. PbO2. Let's try another example. Lead oxide.
This is one that is pretty common that people get wrong. You will see this again,
yes.
or one very similar to this again.
Perhaps
so pay
on a
attention.
test. Lead oxide. But lead is a transition metal, so it is not lead oxide. We need a Roman numeral in the name. Lead something oxide. What is that Roman numeral?
So if we set up the math, just like in the last problem here,
All right.
2 oxygens, each with a -2 charge, gives us a total charge of -4.
-4.
It means we have to have a +4 charge coming from however many leads we have in there.
And there's only one of them.
We only have one.
So in this case, it's +4.
Lead must be +4.
Now, why is this one so confusing?
Well, if you were to follow our rules for the crisscross and you knew it was lead +4 and oxygen -2, you might be tempted to write Pb2O4.
Ah, but you have to reduce those.
Right, so we're looking at a formula that's been reduced.
So if you can't just go backwards and say, oh, there's 2 oxygens, so it's lead 2.
Indeed, you can't just do reverse crisscross.
Look at the math. Make sure they're balancing out to equal 0. Lead 4 oxide.
If any of that seemed confusing, you can always just ask in class, of course. Don't forget that.
Writing a formula from the name. Simply use the Roman numeral and the crisscross method. This is actually pretty simple if you know what the Roman numeral stands for. The Roman numeral stands for the charge. So when it says iron 3 oxide,
that means it's Fe plus 3. Iron, Fe, and then
iron
+3.
oxide. So write the symbols, crisscross, reduce them. You don't need to. There's no ones, so you don't need to remove them. That's what we did in the last section. The Roman numerals are the charge. Another example, we've got lead 2 chloride. So we've told you that lead is +2. You don't have to guess if it's 2 or 4. The Roman numeral is the charge. Lead 2 chloride. Symbols?
Crisscross.
Crisscross. Remove the 1, and it's already reduced. PbCl2. Let's try some other examples. Pause it, see if you can do these on your own, and then come back and we'll follow along.
Okay, welcome back.
Practice number 1, titanium and sulfur. Of course, if you paused it, welcome back. If you didn't pause it, welcome to the practice. Titanium and sulfur. We don't know what titanium is. I noticed that titanium is a transition metal. Number 22, if you look at it on your periodic table. Sulfur we do know, though, don't we?
Yes, sulfur
What is the charge of sulfur?
is in the -2 column. So it's S -2. We know that for sure.
Okay, so I have 3 sulfurs.
3 sulfurs.
Each one is -2.
Each is -2.
And that gives me...
-6.
That means whatever the titanium is has to be +6.
+6. And we've got 2 titaniums.
2 titaniums. And this is what we're trying to figure out. What is the charge of each one of those 2? Total, they're +6, but each one is not +6.
Looks like then each one would be +3.
+3 it is. Each titanium is +3. That's what you're trying to figure out to balance out the sulfurs.
So that tells us what our Roman numeral is right there.
+3,
+3.
-2. +3, that is the Roman numeral because we're trying to figure out the titanium. So this molecule's name, titanium, Roman numeral 3, sulfur.
Well, it's not really sulfur though, because still need to change the ending to the IDE. So it's titanium sulfide.
Sulfide with a accidental subscript E. All right, let's try the second example. VO2. V is a very not common one, but it is a transition metal. Where's that at?
Right next to titanium.
Number 23.
How
about
convenient.
that? VO2. Oxygen we do know. So always start here with the one you know. Oxygen is -2.
And we've got 2 of them.
Yes, we do.
Totals up to...
-4.
Excellent.
That's my anion. Maybe I'll help label these a little bit. My cation.
We need that to be +4
4.
so that the charges cancel out.
And I have
We only have one vanadium.
of them. So we're trying to figure out the charge of that one. If it needs to be +4, there's only one of them.
+4 times 1.
And that is our Roman numeral because the vanadium is 4.
Excellent.
So I'm going to write
Let's see if we can fit this one on here. I'm not very hopeful.
vanadium, Roman numeral 4. I'll go below it.
Nice.
Oxide.
Good save.
I'm a thinker. Vanadium 4 oxide.
Now, you can put parentheses around the Roman numeral, or you don't have to.
Doesn't matter.
Just make it clear that that's a Roman numeral there and not part of the name.
Remember, this Roman numeral goes with that element. It goes right after it, the cation.
All right.
All right. Let's try another one. Now we've got names. This way's a little easier. Roman numeral goes with the transition metal.
So we know that tin's charge is +4.
Tin is Tn, right?
Yep.
So tin is Tn, right?
Tin is Tn. Wait, no.
Tin 4.
Tin is Sn.
What?
It's from the Latin name stannus,
Oh, okay.
which means tin.
Sn
It's one of
plus
those elements.
4.
Yeah.
Okay, so Sn, number 50, if you're having trouble finding it. So remember, sometimes they're from their Latin names. And chlorine is -1. So there's my charges. Tin 4, chlorine -1.
Tin 4?
Tin 4.
Oh, tin 4.
Tin 4, good buddy. Write the symbols.
Do the crisscross.
Criss them and cross them.
I'm not sure if that crisscrossed anything there. Yeah, the tin was already 4. Chlorine was 1.
Redo.
Scratch that.
Let's
Start
pretend
over.
we'll write the symbols. Now you actually have to crisscross them when you're crissing and crossing them. SN1,
So, SN1, yeah.
CL4.
CL4, but we don't put the 1 there.
We remove it. You know, I think I have an eraser.
I think you do too. There it is.
We remove and reduce.
SNCl4, there it is.
Ta-da!
Only took a half hour to get to that one.
Nickel 2-phosphide. Let's
Try
try
this one
one
quick.
more quick example. Let's do blue. Nickel, or nickel, as it is sometimes mistyped, it's French, has a +2 charge.
That's how the British spell it.
Nickel. +2. So nickel +2. Phosphide, not on your periodic table, but phosphorus is -3. There's your two elements. So, Mr. Giacomo, help me walk through this one.
So we have Ni, P.
Write the
So we
symbol.
write the symbols. Then we're going to crisscross them.
Let's
So
see
the
if I can
Ni
do
has a
this.
3 at the bottom, and the nickel has a 2. Or sorry, the phosphorus has a 2 at the bottom.
Already
And
reduced.
It's reduced. We don't need to remove anything. There's no 1s, so it's Ni3, P2.
Nickel 2 phosphide.